Hello all, welcome to my YouTube channel. In this video, we are going to learn about architecture of Apache Airflow. Before that, first we will understand what is Apache Airflow. Apache Airflow is an open source platform that enables data engineers to programmatically author, schedule, and monitor complex workflows at scale. So in the real world project, data workflows are not simple. A simple pipeline may involve extracting data from multiple sources, transforming it, and loading into many systems like data warehouses. Managing these pipelines or managing these steps manually becomes very complex and error prone. So, this is where the concept of Apache Airflow comes. So Apache Airflow allows us to programmatically define workflows using Python and making pipeline easy to maintain, version controlled, and scalable. Instead of guessing what ran or failed, Airflow gives us a clear visual views of the workflow, showing each step and with the current status. Actually, the core concept of Apache Airflow is a direct acyclic graph. You can say as a DAG. Uh, DAG is nothing but a graph of task where each task represents a single unit of work, and that direction in the graph will be defined as a edges. We can say as a executional order. Acyclic means there is no loops. So it don't run endlessly because one task will be dependent on other task, but the mutual dependency will not be there. So it is called as direct acyclic graph. So for this Apache Airflow use case, I'll give you one example. Imagine we have a daily sales pipeline. So in that pipeline, first we have to read the sales from file cloud storage or any particular storage system. The second one is clean and validate the data. And third will be load it into BigQuery or any other data warehouse tool. Then at the end, trigger the reporting dashboard. So these four steps should be executed one after the other. For this, if we create Airflow or a DAG, then it will be very easy for maintaining these steps. So we can consider this as a single pipeline for managing the more tasks. Now we'll learn about core components of Apache Airflow. Apache Airflow follows a modular architecture where each component has clear responsibility. Together, these components ensure that workflows are scheduled, monitored, and tracked reliably. So we'll discuss each component one by one, like coming to this web server. Web server provides Airflow's user interface. So it allows data engineers to view the DAG in graph or tree format, monitor task execution status, check logs of running or failed task, manually trigger or pause the workflows, or you can say DAGs. So for example, if a data load to BigQuery fails, then web server helps you to quickly identify which task is failed and why without checking logs. You can check directly on the user interface. So this is the use of web server. So coming to the scheduler, the scheduler is the brain of Airflow. Its main job is to decide when a DAG should be run and check for a task dependencies. Queue task once upstream tasks are completed means it will also take care of the dependency from another task. Example, if your pipeline runs daily at 2 a.m., then the scheduler ensures that DAG will start exactly at 2 a.m. and data validation runs only after extraction is complete. Without the scheduler, task could not know when or what order it will be running. So then coming to the executor, the executor is responsible for how tasks are executed. It defines where tasks run, whether tasks run sequentially or in parallel. Mainly the common executors are sequential executors. Sequential executor, the name only suggests that tasks are running sequentially. It is for a local testing and all we are using. So another executor is local executor. So local executor, we can have the parallel execution, but in the local executor, we are performing the execution only on one machine. And we have a most important executor, that is Celery or Kubernetes executor. For large scale production system, we are using this executor. We can run the task parallelly in several machines. Then coming back to the metadata database. So in the enterprise setup, hundreds of tasks may run simultaneously. The metadata database stores the airflow state and history. It keeps track of DAG definitions, task execution status, start and end times, and retry attempts and log reference. Those information metadata database will hold. So it will help us to track the many informations. So this is all about the core components of Apache Airflow. Now we'll understand the main architectural view of the Apache Airflow. This diagram represents the architecture of Apache Airflow. Let us understand this diagram. Everything starts with a data engineer or a user. Data engineer writes DAGs using DAGs, nothing but a Python scripts, and places them in the DAG folder. So DAG script should be placed here in the DAG folder by the user or a data engineer. Once it is placed, then the scheduler continuously reads the DAGs from the DAGs folder. So every time if you place the Python script or a DAG inside DAG folder, so it is automatically identified by the scheduler. So main responsibility of the scheduler is check the schedules, identify the which DAG are ready to run, and decide which task can be executed next based on the dependencies. So once tasks are ready, the scheduler creates task instances and update the information in the metadata database. So metadata database will comes to this part, metadata database. The metadata database is a single source of truth in the Airflow. Like most of the information stored in this metadata only. It stores the diagram status, task states such as like queued task, running success, or success and failures task. Then executions timestamps. So all component communicate with this database, not directly with each other. Through this database only, all other components are communicating. So you can see the arrows as well. So all components are communicating with this only directly. And then we'll comes to the executor, this one. So the scheduler sends runnable tasks to the executors. Once it checks the DAG folder. So once everything is checked, it will send the runnable task to the executor. Then executor decides how task should run, like the in which order, and where they should run, like whether it is a locally distributed, whether it can run sequentially, parallelly. So everything will be decided by executor, and this executor assigns the task to the many workers, like according to the executor, whether it is auxiliary, Kubernetes, or a local executor. According to that, it will assign tasks to the workers. So then one more left, which is this web server. The web server reads the data from metadata database and visualize it in the UI. So whatever the information there in metadata database, we can able to see the particular information related to particular DAG in the web server. Like if we want to see any particular DAG, you can say the DAG one, which is created by user one, and it is scheduled as well, and uh, mm, we can see the confirmation that that is executed from last 3 4 days. So all days execution status can be seen in the web server corresponding to that particular DAG. So those information will be fetched from this metadata DB only. Then yeah, this then everything is clear. Yes, yeah, this is nothing but how the tasks are working in the Apache Airflow, or the architecture of the Apache Airflow. This I already explained using last diagram. So this is all about Apache Airflow architecture. So if you have any questions, you can mention in the comment section, and you will get the answer for that. If you want any additional topics about Airflow, then please mention the topics in the comment section. We'll do video on that as well. If this video helpful to you, then please like the video and subscribe to the channel for more videos. Thank you.